So printf is easy. What we're going to do today is that we'll get an overview of the requirements and then the concepts you need to understand to be able to do the project. What is a project structure? How do you implement a printf itself, and how do you test your printf? So that is what we're going to do today. Okay, so let's talk about the overview of the requirements without wasting a lot of time. The first thing you need to understand is that it is a team project. That means that you're going to create a repository and then invite your partner or as a collaborator. And I'm pretty sure you guys know how to do that. I'm going to run you guys through it pretty quickly, and then you're going to see how to do that. So I just go straight to my GitHub, go into your GitHub account, and then the repository that ALX is asking you to create. I'm going straight to the printer project, so just stay with me. Good. Now, the different thing about this project from the others is that with the other projects, you're going to see several files that you have to create in which your source code is going to go. But with this project, all you're going to be seeing is a GitHub repository called printf, and that is all you're going to be seeing. So the difficulty and the challenge is that you may not even know which file to create for which task, and then which code is going to go to which task. And it becomes really challenging, especially when you don't know how to start, how to even go about the whole thing. But before that, just go into your GitHub account and then create the repository. So I'm just going to come here. I'm going to come to new repository. My internet is kind of slow. Sorry about that. I'm going to call this repository bodies. All right. Bodies, you give it whatever description you want to give it here. Just type in some random figures, and then I create a repository. Very simple and straight to the point. You already know how to do this. So the next thing you want to do is to just copy the URL of the repo, which is an HTTPS URL. Go straight into your sandbox. I'm not going to go into my sandbox because the ALX sandbox is really slow. So I'm going to work here in my local terminal. All right. Just as I do usually for you guys. So just going to fire it up. And what you want to do is to just paste. Now before that, you want to git clone that repo. So what I'm teaching you right now is how to set up the project for you and your partner to collaborate. All right. So you're just going to git clone and then paste in the link of the repository. Then you want to get your access token. You guys already know how to generate access tokens, so I'm not going to bother about that. All right. So just generate some access token. Let me just find some random one. Take this one. And then you know what to do with it. You're just going to paste it in, say at github.com. Great. So now I've cloned into the repo called buddies, but your repo is going to be called printf. When I'm done, I'm going to cd into that repository. Now I'm inside the repository called buddies. All right. Awesome. Then the next thing, you just want to create your readme and give it some description. All right. So readme.md, just create it and put in some description. Whatever you want to say over here, just say. Okay. So I'm just going to exit. When I get status, you're going to realize that we've created a new readme file. Okay. Let me clear my screen. You know what you got to do. Just get add. I'm really going fast at this stage because you guys already know the hang of this. You guys already know how to do this. So I'm not going to waste a lot of time through these motions. So you get add, get commit, you give it a message, then you get push. Yeah, go ahead and speak. I'm all yes.
No, I see Georgian turned up. I'm wondering if he's going to ask a question or if he's something.
Yeah. Sure. Go ahead. I've already been interrupted, so I wanted him to go ahead, but no problem. I'm just going to continue. So then you just get to push what you've done to the repository. So now when I go into my GitHub account, now I'm going to refresh the repo. And you're going to see that the README that I just created with the content is reflecting here in my repo. Now, this is what you know how to do. This is what you've been doing all this while. There's no need for anyone to teach you this. But now you need to invite your partner as a collaborator for the project. How do you do that? And I need you to pay particular attention here. All right. When you are inside the repo, you have to whether you or your partner has to first set up the repository. Both of you are not going to have the repository in your GitHub account. Only one person will have the repository in their GitHub account. The moment the two of you have the repository in both of your GitHub accounts, you might risk scoring 0 on the project. That is very critical, so you need to hear me out. Only one person should create a repository, then that one person will send an invite to the other partner to become a collaborator of the repository. So that is what I'm doing now. Assuming I'm the first partner, partner A, okay? So I've created a repo. Now I'm going to invite the next person to come and collaborate to the repository. You see this settings icon up here? You just got to click on it. Then see this left bar over here. You're going to see collaborators. Just click on that. So I'm just going to click on collaborators. Then it's going to bring you to this interface. Then you're going to see that you have the opportunity to invite anyone as a collaborator. Add people. Then you can now enter the email address of anyone. Let me just enter my other email address, okay? Just so that I don't waste a lot of time. So I'm going to say, so I'm just going to invite this email of mine and send an email to myself. Okay. So now, this is what's going to happen. The other partner that you have sent an email to is going to receive a mail, an invite in their mail. So that is what I'm doing right now. I'm going into my mail.
Okay, so you can go ahead and ask.
Yes, go ahead and ask as I wait.
Person who I'm sending the invite point of view so that I can make it much more easier for the person that after they accept it, I'm working on the same like I'm working on different writers. Because I know that after I'm access to things to make on their side of what I'm saying. I'll be working on different branches and every time push them into the main, or we'll all be working on main and then keep on pushing as well.
Okay, I'm going to answer that. That's a very good question. That's a very good question. Okay, so like I was saying, now I'm in the other partner's email address. All right, and this is what the other partner is going to see in their email address. So this is the invite. I'm going to view the invitation. So assuming I'm the other partner currently, I'm going to view the invitation and accept the invitation. So I'm going to accept it. It says that Delio invited you to collaborate. So I just accepted the invite. Now you're going to see that immediately it's going to take you into the repository of the one who created it, the partner who created it. So assuming I'm working with Abena and Abena created a repository, I think Abena, we should share the video that we did this afternoon with them, so that, because that one we demonstrated with you and I, so that's easier. This time around, I'm trying to do and play two roles at the same time, so it might get confusing, but if we share the video we had this afternoon with them, it will be a little bit clearer.
Okay.
Yeah.
Okay, that's not bad. The audio was quite new. I have to use headphones, but for myself, I do.
Yes, I get it. As you can see, it's saying that the invite was invalid because I'm the same person and I've linked both email addresses to this GitHub account already. But at least you get the idea of what I'm trying to say. So what's going to happen when your other partner accepts the invite is that it's going to bring them to the repository that the first partner created. Then you can now clone the repository as the second partner. So because I'm the same person, I can't go through that motion here. But then the other partner just clones the repository to their local system. Then they can push to it, and then they can pull from it. So in my terminal, assuming I'm the other partner, before I do anything, I need to listen to this very carefully. Before I do anything, remember that the partner A has already pushed content to the repository. He created a README and pushed it to the repository. So you, as the second partner, before you do anything, after cloning the repository to your sandbox, you have to get pull. If you do not get pull, you're going to have conflict because there's content upstream that you don't have in your local system. So before you do anything, you always have to get pull. Whether there is information or not, just to be on the safe side, always run get pull before you try to push information to the repository. if there's no information to pull down, it's just going to tell you that already up to date, just like you see in my terminal here right now. So basically, this is it about collaboration. One person creates a repository, sends an invite to the other person receives the invite, clones the repository to their sandbox, and then starts working. So I push, then there's change in the repository that Abner does not have. All right, then Abner will pull, get pull. Then Abner will also push, get push. Then I over here will also get pull. So that at the end of the day, all of us have the same files in our sandbox or our local system. Is that very clear? Are there any questions on that before I proceed? Let me go see what's happening in the...
I have a question, please.
Yes, sure, go ahead.
Just to clarify, are you saying that like if I'm the one that created the repository and my partner has just closed the repository and gets pulled it? From my if I'm the one that created the repository, I get add, I get commit, and get push. Are you saying that I get pulled that repository again after my partner has been pulled? I think that's where I'm.
Here in your question, you are the creator of the repository, right? Good. So you created a repository, you already have content you have pushed to GitHub. Your partner receives the invite and becomes a collaborator. But there is content in the repository that your partner does not have in their sandbox. Okay? So the first thing your partner got to do is to clone the repository. So number one, the partner B has to clone the repository. Okay? When you clone the repository, you have all the information in there. Now, partner B can choose to create a file. Let's say he creates a source file, printf.c, puts in some content, and then the partner will push it to GitHub. But you, the creator of the repository, does not have the content that partner B pushed in your local system. When you go into GitHub, you as the creator of the repository does not have the content that partner B pushed to the repository. So before you do anything and push it to GitHub, you first of all have to get pull to your sandbox. I hope that is very clear. You don't worry. I'm going to share the link of the session that we did this afternoon, and it's going to become very clear to you. Yeah. So I'm going on. So back to my slide. All right.
Yeah, honey, hear me. Okay.
Yes, I can hear you.
I'm using a C-Span before, but it's fine.
So now you have set up your repo. You know that it's a collaborative project that you're about to do. The next thing you want to do is that check the test files. It will give you an idea of what to expect in the project. And the third thing you got to do is to read through the project. Okay, so let's just go and get an overview of this whole thing that I'm talking about. Okay, so let me just go into the project. When you open the project, don't fret. You're going to see a number of things inside. There are some resources that you can read through and all. But that is not the first thing that you should focus on immediately. Okay, now, the first thing that you should do is to come into the test. These are things that are allowed for you to use. But before you do anything, come into the text box, this terminal, all right? It's going to give you a fair idea of what is expected in the printf function that you are about to create. Because this terminal, this gray terminal that you see over here is simply a test file, all right? So ALX at Ubuntu is the user of this gray terminal. And then the cat command, you already know what it does. It lists the content of a file. So what we are seeing here is simply that the content of the file main.c is being listed in this terminal. And then in here, what do we see? We can see a main function, all right? Then we see a variable len declared. This is a variable. Then we see another variable on, we see another variable ui of data type unsigned int. Then we see a pointer that has been declared of a void data type. So this is a void data type pointer. The name of the pointer is attr address. These are things we already know. But this is what I want you to see. You realize that the printf function that you have created is being put to the test. Then over here, the printf function is being asked to print a simple string. and that is what printf does. If you look at the output over here, you can see that that simple sentence has been printed. So this is the output of the first two tests. Okay, so you see first test, second test. Then the second printf test, you see that is printing the length of a string. So you see %d here, and then you see %i, %d, %i, and it's printing the length of a string. So if you come and see the output, you can see those two arguments here. So this is the output of that test. I'm not going to go through everything, but I just want you to have a fair idea. And then the next thing you see, you can see that this one is, let me take the next test, like, let's take %x, okay? So you see that at this place, your printf is being put to the test of %x, which prints an hexadecimal number. And as you can see, the output is correct over here. So basically, what I'm trying to show you is that this gray box you see over here is everything that you're going to do in the project. So if you're able to grasp what is being shown you in this terminal, you are done with the printf project. You take it one step at a time, and then you know all the requirements of the printf project. Okay, so what I'm going to do now is that I'm just going to go into VS Code. Okay, I'm going to show you two very important things. All you need to know to be able to kill this printf project are: number one, how to format strings. Number one, how to format strings. And number two, variadic functions. The others are just coming to help you finish the project up. But if you know how to format strings and variadic functions, you've done 70% of the project. That is very simple. Okay, so over here, let's just try a few things. This is a very simple C function, a C program that we see over here. I'm just gonna get rid of this. Let's just beef it up a bit. Great, I hope you can see my screen. Thank you. So this is a simple C program that you already know. I'm gonna get rid of this. So I'm gonna put the standard library printf to the test, which we already know. So I can print f a simple string. So when I run this code, I'm gonna have a simple string in my output. All right, so as you can see over here, I have a string. I think somebody got to mute their feed. So I have a simple string over here in the output. Okay, one, the printf function must be able to print a string, a simple string. All right, sorry, people just keep calling me. Then number two, the printf function must be able to handle format specifiers. So number two. Okay, wonderful. Now, when you go into the test box, you're gonna see first that you have to take care of %d, which you know prints an integer, then %i, then I also saw %c. Okay, now watch something carefully. The entire project is divided into two categories. Okay, if you look at the first task 0, it says that write a function that produces output according to a format. Then it gives you the prototype of the printf function that you're supposed to create. Now hear me out carefully, because this is very important. The second requirement says that the function that you're going to create is supposed to return the number of characters printed. Okay, I'll explain that to you. Then you're supposed to write the output to the standard output, and then the format is supposed to be a character string. Then now, for the first task, you're not supposed to do much. All you have to do is to make sure that you handle the format specifiers, %c, %s, and then the %sign. What do these things mean? Okay, I've been talking to you about format strings. Format strings. What is a format string? Now, if you give printf a string, let's say I tell printf that my name is Leo. If I give this string to printf, what is printf gonna do? Printf is just gonna echo it back to me. printf is just going to echo it back to me because it's a simple string literal. Okay, but now I can decide to give printf a format string. I'll tell printf that my name is a placeholder, which is %s. Okay, so now what I'm doing is that I'm creating a format string. So I tell printf that my name is %s, and printf understands that this %s over here is supposed to act as a placeholder that is going to hold a certain argument. The %s over here, printf understands that it's supposed to be a placeholder that is going to hold a certain argument. When that argument, I can give it to printf and tell printf that that argument is going to be Leo in quotation marks, in parentheses. So what you see over here, my name is %s, then I give printf the argument Leo is what is called a format string. It is this, what you see over here is what is called a format string. And according to the task that you have been given, this is the first thing that you are supposed to do. You are given the prototype of the printf function and you are given the parameters, and the first parameter of the printf function you are given is a format string. That is why you see the character data type over here. The const you see over here simply means that it's a constant, which means that whatever format string you supply to the printf function cannot be altered. All right, then these 3 dots you see over here represent a function that can take many arguments. What do I mean by that? So let's go into our Visual Studio Code and let's create a very simple function that adds 2 numbers. So let's create a function and call it int add. Then inside that function, we are gonna take 2 parameters. So int number 1 and int number 2. Okay, then inside that code, we are going to return number 1 plus number 2. Very simple, very simple. Okay, now if I come into my main function, I'm going to get comment out this print string. Let me comment it out. All right, then inside my main function, I'm going to call my add function. So I'm going to say add 2 and 5. Okay, or let me give it to a variable. Okay, so let me say int sum equals to the function. No, if I use Betty, it's gonna change it. It's gonna take a lot of time. So let me just go with the explanation. Then later when I'll come in with Betty and all that. Okay, so I've called the function over here, which takes 2 parameters, num1 and num2, and I'm telling the function to add 2 and 5. So when I run this code, I'm supposed to get 7. Okay, let me run it again. Just get rid of this terminal. Sometimes I have this problem. Oh, hold on, I've not printed the sum. Come on, sorry about that. So I'm gonna printf sum. Because it's an integer, you know we're gonna use %d. Then we're gonna print sum. Very simple. As a matter of fact, let's put it on the new line. Okay, so I'm gonna run my code one more time. As you can see, the function that I created returns 7 because it adds num1 and num2. But here is the problem. If I increase the number of arguments that the add function takes, it's supposed to take 2 arguments, as you can see, num1 and num2. But here in the case, I've given it 3 arguments. So I'm going to run my code again, and then immediately it tells me that I've run into an error. Now, I've told the compiler that the function I'm creating called add is supposed to take 2 parameters, num1 and num2. But in calling the function, I've given the function 3 arguments. It doesn't work that way in C, all right? But for some reason, as for printf, whenever we use the printf function, we can give it so many things and printf does not get tired for some reason. So I'm gonna printf. Let me just comment this out. All right. So I'm gonna printf and I'm gonna give it the first argument. I can tell printf that my name is Leo, just like I showed you. And then you know printf is gonna print this for me easily. Okay, very simple. So I can also tell the same printf, which is a function, all right, that my name is, and I'll put a placeholder here and say %s. Then I'll tell printf that the %s is a placeholder for the argument Leo. Okay, now when I print this, it's supposed to go in quotes. So Leo. Now when I print this, you're gonna realize that printf will immediately give me the output. My name is Leo, just as you can see down there. Now I can also tell printf that in the same output, so my name is %s and I am 31 years grown. All right. So instead of putting in the 31 here, I can put in a format specifier, %d, and I'll come and tell printf that the %d I gave to it is actually the number 31. Okay. Then I'm going to print this out. And as you can see, printf wouldn't shut. It tells me that my name is Lou and I'm 31 years old. And I can keep giving printf arguments over and over and over again. And printf doesn't seem to get tired of arguments. For some reason, printf is able to take so many arguments without getting tired. And the question is, how does the function printf do that? All these things that I'm telling you is what is going to determine how you implement your printf function. Because your printf function is supposed to be a replica of the printf of the standard library. So that means that everything that you know that the printf does, your printf that your custom printf you're going to implement should also be able to do that. And then we can keep going on and on with several format specifiers. We don't have the time. Make time and read, %s, %c, whatever. But you don't have to focus on everything. All you have to focus on currently are the format specifiers that ALX is asking you to implement. And for the first task, it says that you should implement for %c, %s, and then the %sign. Why the %sign? Because it's a special character. For instance, if I want to printf again, if I say printf and I bring %, immediately printf sees %, it knows that I'm going to bring a certain format specifier. So if I print this, I'm definitely going to run into an error. It says %. What is %? It's expecting an argument. So if I want to print the %sign itself, it means that I have to bring another %sign to escape the first %sign. Now when I print this, I'm safely going to get the %sign, as you see over here. Okay, and then there are other special characters such as the backslash and many others. So the first thing that ALX is asking you to do is to implement a printf function that is able to print the %c character, the %s, and the %sign. That is all you are going to do for the first task. And this is the first mandatory task. Look at it carefully. This is mandatory. Then the second task is also mandatory. And for the second task, you're supposed to implement %d and %i. And they are saying that you don't even have to take care of the flags. You don't have to take care of the width. You don't have to take care of the precision. You don't have to take care of the length modifiers. All you have to do is just handle %d, %i, and over here, handle %c, %s, and the %sign. You don't have to handle the weight, the precision, the length, and the flags. And that is all the project is asking for. So if you look at it carefully, the tax 0 is a mandatory tax, tax 1 is a mandatory tax, and the rest are all advanced tax. Guys, look at this. This simply means that if you are able to do task 1 and tax 0 and tax 1, you have 100% on the project already. Everything else is just going to be extra marks. So what is the need of fretting over here? If you manage to conquer task 0 and 1, you already have 100%. You see? So why the panic? Okay, so you just have to take your time. Make sure that you kill the 1 and the 0 and the 1 very well. Then you are at peace. You know that whatever else I'm doing is just extra marks. Okay, and that is very important to understand. And interestingly, to be able to do the 0 and the 1 is very, very simple. And that is what I'm showing you. I've already taught you about functions. If you not watch it, you already know where to find the videos. Now, this is a function called printf. This is the return type. This is the name of the function. underscore printf, and as you can see, you are seeing a format string over here. There are two main ways of declaring strings, and this syntax shouldn't confuse you. And then the 3 dots you see over here represents a function that can take multiple arguments. Just like I showed you, the add function that we created is supposed to take num1 and num2. Now we added a third number and we run into errors. But as for printf, printf can take so many arguments without getting tired. And the reason is that it falls under the category of a class of functions known as variadic functions. So if ALX is asking you to implement a printf function, then you know that you are about to implement a variadic function. It's very simple and straight to the point. And how do you implement variadic functions? We don't have a lot of time, so we're going to meet tomorrow too at 6 p.m. I'm going to take my time and break them down for you properly. But for today, it's just an overview to give you like a fair idea of what to expect for the project. So for a variadic function, you know that you have to bring the return type, assuming it's an integer. Bring the return type, then the name of the function. So let me say function name. All right, then the parameters that the function is supposed to take. What you do is that you bring the first parameter. You bring the first parameter, and for ALX, the first parameter that they gave you is a format string. I told you there are two ways of declaring strings. To declare a string, you can either do char, they bring the name of the string. Let's say we call the string str, and you bring your array, which is this, and you see that this string is called Ishira. Right? My pencil is acting up. Okay, don't worry. Sorry. Then the second way you can declare a string is to declare a format string. Okay, so I can also say char, and instead of just bringing the string, I can indicate that the string is a pointer. Okay, then I'm going to see that this string is called Abena. Okay, so all these you see over here are ways of declaring strings. Now, ALX is not using the first way. ALX is using this format. But for some reason, they want you to understand that this string that you are declaring cannot be changed. So they are telling you that it is a constant. And whenever you see the constant data type, it simply means that the variable, the value of the variable you have created cannot be altered. It remains constant throughout the execution of the code at runtime. So that is simply what this constant means. So ALX tells you that the first argument for this printf function is a format string. So it's a constant. Then they bring the name, the data type of the function, the parameter, which is char. They let you understand that it is a pointer that points to char, that points to the name of the string, which is what? Format. So this format you see over here is simply the name of the string. They could have named it anything. They could have named the string, they could have named it whatever, they could have named it Ernest or whatever name there is, but they decided to call it format. Then when they were done, they brought three dots for you to know that it is a variadic function. And there is a way by which you implement a variadic function for you to know how to take multiple arguments. For you to do that, there is a standard library that you need to import, which is the standard std arg. My pencil is really acting up today. I don't know why. So let me just type it out so that it comes out really clear. So this is what I'm talking about. Include the standard argument. All right, .h. Then, as you know, this standard argument allows you to use 4 very cardinal functions. The first one is the variable argument list. The second one is the variable argument start. And the third one is the variable argument arg. The final one is the variable argument end. And interestingly, when you look into your project requirements, these are the same arguments that ALX is saying you can use. So you see write, you see malloc, you see free, you see the variable argument start, variable argument end, variable argument copy, variable argument arg. So let me leave you with these final words. Today, I just came to give you an overview, just to let you have a general overview of the project. Let me give you final words before I open the room for questions. Number one, when you open the project, go into the text box. The text box is going to give you, I'm talking about this text box, it's going to give you a fair idea of every functionality that ALX is looking for. Then when you are done going through the text box, look at the prototype of the function printf. The moment you look at the prototype of the function printf, it tells you that this is a variadic function. Right now, you know that as you are leaving this meeting, you're supposed to go and read about string formatting. Go and watch YouTube. I'm going to leave some links. I'm going to drop some resources for you. Go and read about string formatting. Number two, go and learn about variadic functions. Two very important things. If you're able to do that, now you realize that the project becomes very doable for you. Then one last thing, you realize that now with the advanced stacks, ALX is just telling you to execute more functionality to your printf project. And each functionality is a file. Okay, so if I come to, let's say this task is asking me to handle the following conversion specifier, which is P. And you know that %P prints the address of a variable. It's a pointer. So when you want to print the address of a variable, you use %P. So all this task is trying to tell you is that create the functionality that handles pointers. And immediately you know that you have to create a file for that. So each question is a file of your own choosing. You can name the files anyhow you want. So for something like this, you can name it pointer.c, right? Don't worry about the names of the files. You don't have to go to GitHub and copy someone's code and their file names. Just name the files in a descriptive way that you think you can name it. And then each task is a file of your own choosing. So name it. So for instance, for something like this, ALX is talking about flags. We see that handle the following flag characters for custom specifiers. And over here, it's talking about length. And over here, it's talking about custom conversion specifiers. Over here, it's talking about non-custom conversion specifiers. Now, let me just get rid of this and show you what they're talking about. Okay, you already know what printf function does. So assuming, let me just show you this and then I'll conclude, right? So assuming I wanted to printf, let me just bring in some symbols just to make this really clear. So I'm bringing these symbols, okay, so that you can have a fair idea of the width. If I want to print, let's say an integer, %d, which you know, and I'm going to say that I want to print the number 17, okay. Now when I run this code, let me put it on the new line. When I run this code, it's just going to print the number 17. That is it. You see right here. So it prints the number 17. I don't know why I'm having a problem here, though. Okay, I know. I see where the problem is coming from. This code is supposed to come here instead. I hope you guys are there. So I'm going to print this, and it gives me the number 17 inside those vertical signs that I created. So this is the usual thing that you know, but there's also something called a width of a function. So assuming I wanted to add a width to this integer, I can just come between the % and the d, and I'm gonna put the figure 10 over there. And when I print this, you're gonna realize that suddenly there's a width that has been created before the integer. So anytime you see width for printf function, this is simply what they are referring to. I put a figure between the % and the integer, and it created this entire space you see over here. And then they also have something they call flags. A flag is something that you give to a variable to left align or right align it, right? So for instance, if I put a dash flag over here, a negative sign, and I run this code, now it's suddenly gonna give me a right align. So you see that this time around, the 17 has been pushed forward, and then there is a space over here. But when it was positive, the 17 was right aligned. When it was negative, now the 17 is left aligned. It's very simple. So this is what is referred to as width. So the 10 over here is a width number, and the dash is what is referred to as a flag, right? And that is very simple. And then they also have something, the printf also has something that is referred to as a precision. Okay, so for instance, this time around, I want to, let me put these vertical signs here so that at least I give it some width. Let's say this time around, I want to print a float. So I go %F, and then the float that I want to print is, let's say 5.0. All right. Now, a float number can take a precision. So now, instead of just printing 5.0, let me just run this code and let's see what we get first. So for this code, we get 5.000000. But what if I didn't want 5 decimal places? I only wanted 2. So that is where the precision comes in. So over here, I'm just gonna put a precision here, and I'm gonna say, let's say I want 0.2, 2 decimal places. So now when I run this code, I'm gonna have only 2 decimal places. So you can see 5.00. This is what is referred to as the precision. Okay. So for the first one, we handle the width. So this is the width, the 10 you see over here. Then the second one, we handle the flag. This dash you see over here is the flag. And then the third one, we handle the precision. So the precision you see over here is the 0.2. It gives this float value a certain number of decimal places. And you can see that printf is able to do all these. So what ALX is asking you to do with some of the tags is that for some of them, they're asking you to handle flags. For some of them, they're asking you to handle format specifiers. And then for some others, they're asking you to handle precision. And then for some others, they say that you can ignore all of them. So for, let's say, this first and second task, they say that ignore the flag, ignore the precision, ignore the width, ignore the length. So you're not supposed to bother yourself with the functionality of your printer being able to do all that. But for the advanced task number 7, you have to handle some flags, which is this. You have to handle the space, you have to handle this pound sign. And then for I think basically that's it. For the field width, the precision, and then the flag is only advanced task number 7 that is requiring it. The rest are just format specifiers and binary numbers. So I think for the task number 4, it's talking about, I think, hexadecimal number. Yes, and hexadecimal number. So you're supposed to create a format specifier that takes care of the capital S and then the small x. All right. Now, back to my concluding statements again. So basically, all I'm trying to say is that, where is my Google? Yeah, here you are. Basically, all I'm trying to say is that printf is easy. ALX is not asking too much from you. They only give you 2 mandatory tags. If you do that, you have 100%. So go and read about string formatting. Then go and read about variadic functions. I'll drop some resources for you, the page and all. Then take your time and go through the requirements of the project. For today, all you have to do is to get a fair idea of, okay, this is what printf is able to do. And then I'm also have to come up with a way of finding out how to do those things that printf is able to do in code. And I've already told you that you're going to use variadic function. And I've also told you that each task you see, you can create a file for it. Basically, that's all you have to do for the project. If there are any questions, I'm going to open the floor now. You can quickly go ahead and ask before we go our separate ways. Are there any questions? Yes, Daniel.
Yeah. Are we still meeting the same time?
Yes, tomorrow we are meeting at 6 p.m. Reverend, you have something to say?
Not really. I have posted most of the resources I think will be beneficial
Awesome.
to the chat box. So I hope everybody is able to access it. I noticed that some people joined later and some kept just connecting. So I reposted most of the links.
Awesome.
Make sure you look through them. They are mainly on how to collaborate.
Yeah, I know, right?
How to customize your own video. That's just like by the way. There's this very brief YouTube video on how to understand the special characters, format specifiers,
Awesome.
things.
Awesome.
And I had some sporadic finance stuff going. So
Lovely.
I also added the recording of our session.
Great. You have solved everything for them. You guys are blessed.
Yeah, if they are able to access the chat, because I think once you on the call, they will use access to that too.
That's true.
So I've also copied and pasted them on the WhatsApp.
The group, excellent. Okay. So that would be great then. Yeah. So that would be about it for me. I actually have to pop out and jump on.
The live learning session. Okay. That's really cool.
Yeah. So,
Actually,
that has been good.
have a round.
Yes. That's what I'm gonna work on that. I'm going to add her, don't worry. Yes, exactly. She's afraid. She's afraid that you worry her, but
Anyway, but like yes, like I said, it's nothing big that you have to be scared of. And again, it's just like 3 questions for the mandatory. So if you're able to solve those ones, that's like basically half the project.
that's right.
Yes. So just handle it and set, and then you'll be fine. But then again, I mean, since you have a good connection, you have a better question, you can just post them and then see how best you can support you.
Amazing.
But it's going to have a person. This is my friend of the course. Hi, friend. Thank you. But I hope you've understood what I've said.
I know it was a bit rushed, but at least it's an overview.
Hello, Mr. Yeah, I want to ask that the whole reason for collaboration, such that maybe we've been given so many functions to it. Like maybe even if you are doing the advanced search, and like as you stated, every function has a file that we are created for it. So does it mean maybe assuming Leo is my partner and we collaborated, and maybe I create file 1 for the task 0, and maybe Leo creates file 2 for task 1. Then like is that a whole reason for the collaboration thing? I mean, I know we are doing it in groups, but in case I do maybe task 1, not that we are doing it together, but maybe I created the task 1 file and I did it in my repository. Leo pulls it to his repository and maybe does task 2. I just want to understand that is that how we go about the project? Even if we are doing it together, yeah. Or one person creates all the files in their repository and the other gives to. Yeah. No.
So go ahead. Talk about it.
We're actually talking of. Okay. Okay, Isra, if I had your question right, you are asking how to go about the collaboration. I think about the file creating and doing the work together is between you and your partner maybe. Unfortunately for me, my experience for Princess wasn't the best. I initially had to do everything from scratch by myself. The collaboration was quite hectic, but you just can't do the work by yourself because if you do everything and you post everything to your industry, you still need your partner to pull and push. That's if I use the pull and push method. There are 2 methods: pull and push and the branching. I don't recommend the branching because it's not beginner friendly. So just stick with the pull and push method as I have added the resource. So if you check the resource, you see the steps on how to do that. But basically, what's going to be done is however you decide to go about the work. Like if one person decides to do the work, if you decide to do the work, you share the work amongst yourselves. Bottom line is, these are the important things that you should remember. The repository should be in one person's GitHub account. That's a must. Like the minute you talk or you create the repository in 2 accounts, it's a 0. So if you are 2 partners, partner A creates a repository in their GitHub account. they send an invite to partner B. Partner B will accept the invite, close the repository. So you know when you're closing in your terminal, you usually use your personal access token, and then you use your username and then the repository name to clone. But if partner A takes that account, it means the username is partner A's username. When partner B is cloning the account, they do not change partner A's username. They just add their personal access token. And once that is done, the collaboration begins. Now, whoever takes a file at any point in time and pushes, whoever is on the other end going to revisit the repository must do a git pull. Even if the other person just pushed the file without editing anything, once you are going to go back into the repository, you have to do a git pull. Make sure you always git pull is pushed to avoid conflict. Now, you can't do all the files in your repo and then just make the other partner git pull. The minute you do that, there's no collaboration, there's no commit. If you have time, maybe, or if you go look at the videos, they will see how the collaboration is and the commit and the insights. Because at least the collaboration should be a 40-60%. So let's say if you are pushing the files and you do like 20 commits, and your partner does a git pull, it's not less. But if your partner does a git pull, that means if they push, they only had one commit. And that's very poor collaboration, because then it's like 20 commits as against one commit. That's like 90-10% collaboration. And you get zero. So if you look at, I think when you open the intranet, you could see contribution was 100%. So the contribution is poor as well. And note that the weight of the printed project is 5. Unlike the other projects we can realize 1, 1, 1, 1. The weight of the printed project is 5. So if a grade is a bit shaky and you do not perform in the printed project, it's going to drop you down, which is going to affect you. I'm not trying to scare you, but I'm just basically saying that because the project, the mandatory is just 2%. Whatever the case is, you focus on getting those 2% right, which will be 100%, and then your average is 6. You get it? So basically, so I left the point. I don't know if I answered your question for her, but essentially, collaboration has to change. You have to work in sync. Helen, I noticed you left the call, so you might have missed some aspects of my explanation. But
Yeah, my network was messing up, but I understand what you're saying.
Great.
I understood what you said. I just wanted to understand in case of not us working with it, but we are working together.
Mhm.
However, just give tools to make sure that we are, yeah. But I understand what you
Yes.
said.
Good. So you have to work in sync. Whatever the case, you have to work in sync. Make sure that your collaboration is at least 40-60%. You don't have to have a lot of comments than your partner.
Oh, okay. I think what you just said is answers my question.
Great. Okay. Your meeting.
Yeah, I realized that I was talking on me, so I just had to take myself off. So this is what Irabna was talking about. When you go into your GitHub, you see these tabs up here. You're gonna see one of them called Insights. Okay, so this repo so this is what I was talking about. When you look at the tabs up here in your GitHub, one of the tabs is Insights. When you click on that Insight, you're gonna see the contribution graph right over here, and then you're gonna see the percentage contribution of you and your partner. For this repository, I'm here alone, so you're not gonna see, the contribution graph. But if you go into other repositories that are collaborative repositories, you're gonna realize that the insight is gonna show the contribution graph, so that the range shouldn't be too disparate. Okay, at least if it's 60-40, it's not bad. If it's 70-30, then maybe that's not cool. But at least 50-50 is the best. But I'm not sure you guys will have 50-50. Probably end up having around maybe 50 something or 60-40 thereabout.